Hi all, welcome back to the Testing Mentor. Today's tricky question is, how would you design an automation strategy for a microservices architecture? Imagine you're testing an e-commerce system, but it's not one application. It's order service, payment service, inventory service, user service, notification service, and recommendation service. Each independently deployed, each version separately, each with its own database. And the interviewer asks, how would you design an automation strategy for this? If your answer is, I'll automate end to end scenarios through UI, you're thinking monolith. Microservices demand a different testing philosophy. Today, I'll show you how senior SDETs approach this strategically. This question evaluates, do you understand distributed system complexity? Do you understand failure isolation? Can you design fast feedback loops? Can you prevent integration chaos? Do you understand trade-offs between speed and coverage? Microservices introduce network latency, partial failures, eventual consistency, version mismatches, backward compatibility concerns. Your automation strategy must account for all of this. This is architecture level thinking. Before designing tests, I analyze what are service boundaries, what does each service own? Does each service have its own database? Are services tightly coupled? Is communication synchronous or asynchronous? Is there an API gateway aggregating responses? Why this matters? Testing tightly coupled services is very different from testing loosely coupled ones. Without understanding ownership and boundaries, automation becomes guesswork. In microservices, testing everything end to end is dangerous. You know why? Because one failure could be caused by service logic bug, the next one could be network timeout, there could be schema mismatch, it could be a database issue, authentication problem, downstream service failure. If all tests depend on full integration, debugging becomes inexpensive. Instead, test as close to the source as possible. This is the first big maturity signal. In microservices, your pyramid changes shape. Layer 1 is unit tests. Developers validate logic locally. Layer 2 is service level API tests. Validate endpoints in isolation. Layer 3 is contract tests. Ensure service compatibility. Layer 4 is integration tests. Test small service combinations. Layer 5 is end-to-end tests. Only validate critical user journeys. Why minimize end-to-end? Is because they're slow, expensive, hard to debug, and environment sensitive. This is strategic thinking. For each microservice, I design a dedicated automation suite that covers functional validation, that is positive scenarios, negative scenarios, edge cases, non-functional validation, that is schema validation, response time validation, authentication, and authorization checks, isolation strategy, that is mock downstream services, use control test data, and avoid dependency on full stack. This ensures fast feedback, clear ownership, reduced integration risk. In distributed systems, services evolve independently. Imagine order service expects order ID, amount, and currency. Payment service suddenly removes currency. Now, order service breaks. This is where contract testing becomes critical. Consumer driven contracts ensure if you change your API, you don't break consumers. This prevents production surprises. Interviewers love when candidates mention this. Now, consider asynchronous architecture. User places order, event published, inventory updated, notification sent, analytics triggered, but processing is not immediate. You now deal with eventual consistency, retry logic, duplicate messages, out of order delivery. Automation must validate event emission, consumer processing, idempotency, dead letter queue behavior. This requires polling strategies and message verification logic. This shows advanced distributed knowledge. In microservices, test data complexity increases because each service owns its own database. Strategies include ephemeral environments, seeded databases before test execution, data factories generating unique payloads, reset scripts post execution. Never depend on shared unstable data. Stable data strategy is equal to stable automation. In CI pipeline, On each commit, run unit tests, run service level API tests. On integration branch, run contract tests, run integration tests. Before release, run minimal end-to-end suite. Parallelization is critical. The goal here is fast feedback at lower layers, confidence at higher layers. Automation in distributed systems must integrate with observability, include structured logs, correlation IDs, distributed tracing, clear error reporting. When a test fails, you should know which service failed, why it failed, at which hop. This signals real world experience. In interview, answer like this. Start with understanding architecture. Warn against overusing end-to-end tests. Redefine testing pyramid. Emphasize service level API tests. Introduce contract testing. Address async systems. Discuss test data control. Explain CI/CD layering. And mention observability. That's a senior level systems answer. If you want to prepare for product company SDET interviews at this architecture level, I offer limited one-on-one mentorship sessions. You'll find the email ID in the pinned comment below. Thank you for watching.